Alright guys, so we're going to be working on systems review. Alright, so we're going to be reviewing systems. And there's three ways of reviewing, solving systems by graphing, but we're not going to be doing any graphing here. Alright, we're just going to be doing, we're going to be doing it algebraically. So substitution and elimination. I'll show you, I'll show you one of each so that, or a few of each, I should say, so that hopefully you'll start to remember. And you'll notice as we go through some, I already have answers down for some of these word problems. A couple of them I'll work them through. All right, but I'll uh, I'll start you off on all of them just to make sure you understand them. All right, so this first one we're gonna do by substitution method. And substitution method, it's way easier when they're written next to each other as opposed to right on top of each other like these two are. All right. All right, so it's much easier when they're written that way. And it's also much easier if I can label them. All right, so I'm not sounding like a Neanderthal and trying to highlight and everything. I just equation one, equation two. All right, now when we do substitution method, what we're looking for is we're looking for one of the equations to have a variable that's by itself. So if you look at equation one, y is by itself, all right, or there's a 1 in front of it. There's a coefficient of 1. So what I'm going to do is I'm going to solve for y. And it's real easy in this case because y is already by itself. So all I'm going to do is subtract 5x from both sides. So I have y is equal to negative 5x plus 8. All right, that 8 and that negative 5x are not like terms, so you can't combine them. Just put them next to each other. All right, now here's the reason why they call it substitution. Is I know what y equals. Y is equal to 5x, negative 5x plus 8. So I'm going to go into equation 2 and replace y with negative 5x plus 8. All right, so I'm substituting. I'm getting rid of the y, and I'm going to substitute that negative 5x plus 8. All right, make sure that everybody knows that's supposed to be a negative 10. All right. So just like you've always done, distribute, distribute, okay? You know what to do. So negative 3x minus 10x plus 16 is equal to negative 10. Combine our like terms, all right? There's our like terms right there. So I have negative 13x plus 16 is equal to negative 10. Subtract 16 from both sides. All right, we end up with negative 13x is equal to negative 26. Divide both sides by negative 13. X is equal to positive 2. All right, now what am I going to do? I'm going back to equation 1. We're already solved for y because I need to figure out what y equals now. So what I'm going to do now is I'm going to substitute this 2 in for that x. I'm substituting. All right, so I have y is equal to negative 5 times 2 plus 8. Negative 10 plus 8. So y is equal to negative 2. Now, when you're writing your solution, remember this is where these two lines cross. This is where the solution to these two equations. Remember the x goes first, then the y. Don't screw this up. To negative 2. All right, so number 2, there's the answer. Number three is an infinite solution, meaning that, or all real numbers. All right, depends on how your teacher says it. What this means is when you solve for one of the variables, regardless of which way you solve for, you're going to notice kind of everything cancels each other out. You're going to eventually end up with 0 is equal to 0. And in this case, the reason why that happens is the lines coincide. The lines are right on top of each other. All right, those lines are right on top of each other. So we say that those lines coincide. And all that means is there's a whole bunch of solutions. There's an infinite amount of solutions. These two lines are touching everywhere. as opposed to these two lines up here. All right, these two lines, if I graphed one and then graph the other, they're only touching in one spot. Well, these two lines in number 3 are touching everywhere because the two lines are right on top of each other. All right, for number 4. Number 4, I chose to do this one using elimination method. All right, number 4, I'm using elimination method because if you look at the equations, neither equation has a variable that's by itself. All right, there's no equation that's by itself. So equation 1 and equation 2, there's no variable that's by itself. So in this case, I want to leave them stacked on top of each other. All right, so I'm going to leave them stacked on top of each other like this. Sorry, it's supposed to be an 8. And the reason why I want to leave them stacked on top of each other is when I look at these, I don't want to try solving for a variable because then I'm going to end up with some funky fractions. So when I look at these, the reason why I'm going to leave them stacked on top of each other and use elimination is there one of these equations that I can multiply something by that will give me the same exact number as the other one? So if I look at this right here, if I multiply equation 2, by positive 2, if I multiply that by positive 2, I end up with negative 10x plus 6y is equal to negative 18. I'm not going to do anything to that top one because I want you to see what happens. All right? I want these two things to be exactly the same except for the signs to be different. Do you agree they're exactly the same and the signs are different? Yes. When that happens, we add them together. These cancel out. That's what we want to have happen. We want one of the variables to go away. So now negative 8 plus 6 gives me negative 2y. 4 minus 18 gives me negative 14. I'm just adding those two equations together. I'm doing it at the same exact time. Okay? Add those two together. Now divide by, solve for y. So I'm going to divide both sides by negative 2. Y is equal to positive 7. Now, it doesn't matter which equation I go back into. All right? I can go back into equation 1 or 2 and substitute. Now, so I am going to substitute again. I'm going to substitute y in. I'm going to substitute 7 in for y. Excuse me. All right? I'm going to plug in 7 in for y. It doesn't matter which equation I'm going to go into. I'm going to choose to go into equation 2 just because the numbers are smaller and I'm lazy. So negative 5x plus 3 times 7. You notice I replaced y with 7 equals negative 9. Solve just like you've always solved. All right. Subtract 21 from both sides. I have negative 5x, that goes away, is equal to negative 30. Divide both sides by negative 5. X is equal to positive 6. So my solution to this system is 6, negative 7. And I forgot to mention it in equation 1, in problem 1. But go back and substitute. All right, make sure that this is a solution. You guys remember how to check it. I'm not gonna go through that again. All right, so number 7. Here is these word problems. And I want to make sure that you guys are okay with the word problems. So when I read these word problems, I know I'm going to have two equations, all right? And I'm going to have two variables. Now, I'm always going to use x and y. Some people use different variables for different things. I don't care what you use. I'm always going to be using x and y, all right? Now I have to define them. And where I define them is I look at the question. What are they asking me? That's how I define them. So X is how many student tickets were sold. You notice I didn't even read the question yet. I didn't even read the question. How many student tickets were sold? So X is going to be the number of student tickets sold. Right? Didn't even read the question yet. Y. How many non-student tickets were sold? So the number of non-student tickets sold. All right. So I start off there. Now the next thing I want to look for, all right, let me erase some of this mess. The next thing I want to look for what are the totals? All right. Because when I set up my two equations, that's what I'm going to have it equal to. So my totals, do you see any totals in here? Yes, there's a total of how much money they made and how many tickets they sold. All right. So they sold 214 tickets and they made $1,973. All right. That's how much they made. So those are going to be my two equations. Those are going to be my two equations there. And in this case, I'm going to solve them using substitution. All right. So, excuse me. All right. I'm going to solve these using substitution. So I'm going to have the two equations next to each other as opposed to right on top of each other. So what was one of them? One of the totals was 214 tickets. How do I get 214 total tickets? Well, how many student tickets were sold? I don't know. How many non-student tickets were sold? I don't know, but I know together they sold 214. Now, how do I get 1973? All right? So that's in dollars. Now I'm going to go up here and look for some dollar amounts. There's a dollar amount. All right, so there's the dollar amounts. How do I get these to this equation set up? Well, I know student tickets were $7. Well, how many student tickets were sold? I don't know. I know non-student tickets are $12. How many were sold? I don't know. But between the two, they made $1,973. All right, so in equation one, I'm going to solve for one of the variables. It doesn't matter what you solve for, right? So I'm going to solve for x. So, I'm going to get x by itself. So x is equal to negative y plus 214. Just like we did before. I'm going to take this and plug it in for x. All right? So I'm substituting here. So 7 times negative y plus 214 plus 12y is equal to $1,973. Distribute, solve. All right, you know the whole drill. You know how to do this. So I have negative 7y plus this big old number 1498 plus 12y is equal to 1973. All right, I'm going to combine my like terms. So I end up with 5y plus 1498 is equal to 1973. Subtract, all right. Sorry, my writing's getting really sloppy on here. And I end up with 475. Divide both sides by 5, y is equal to 95. All right. So I know there were 95 non-student tickets sold. Well, how do I figure out how many student tickets were sold? I need to substitute. So I'm going to substitute that 95 in for y. All right. So x is equal to negative 95 plus 214. X is equal to 119. This is not good enough here. I'm going to tell you this right now. This is not good enough. Tell me what these things mean. All right. What does X represent? X represents the number of student tickets sold. So there were 119 student tickets sold. And there were 95 non-student tickets sold. All right. This is what we're going to be looking for. That's what we're looking for. I'm not looking for this mess right here. That's what I'm not looking for that. This It's not wrong, but this is much better. That's much better. All right, number 8. Again, I need X and Y. And what are they asking? Find the cost of bag of chips and pretzels. All right. So I haven't even read the problem. But what does X represent? The cost in dollars. The cost in dollars for a bag of chips. And Y is the cost in dollars for a box of pretzels. All right. So now that we know what their variables are there any totals? Any totals here? Yes, there's a total of 513. There's a total there. All right, so I know some totals. So $5.13, $3.09. All right, now let's go back and figure out what the hell they're asking. What are they talking about here? So Michael buys 2 bags of chips, 3 boxes of pretzels. He spends $5.13. He then buys another bag of chips and 2 more boxes of pretzels for $3.09. All right, so with this one, I would solve this one personally. I would solve this one um, elimination. All right, because so I'm gonna set the 2 equations up next to each other. All right, so I have $5.13. How do I get $5.13? Well, the first time he says he buys 2 bags of chips. He buys 2 bags of chips. How much do these bags of chips cost? I don't know, but I know he buys 2 of them. Plus, how many boxes of pretzels does this kid buy? He buys 3. 3 boxes of pretzels. How much do they cost? I have no idea. But I know these 2 bags of chips, these 3 boxes of pop pretzels. He spends $5.13. Now the next time he buys he buys another bag of chips. So he buys 1 bag of chips plus 2 more bags of pretzels, and he spends $3.09. All right. In this case, I would multiply equation 2 by -2. All right. If you look at it enough, if you multiply equation 2 by -2, these two things will cancel each other out. Okay. So the final answer, I'm gonna let you guys do the work. I just wanted to set you up. The final answer is um, bag of chips cost 99 cents. Box of pretzels costs what was the cost? $1.05. Okay. All right. So again, please try to do the problem yourself. Number 9. Again, what am I looking at? Right away. Right away. I didn't even read the problem. How many of each type of tickets did you sell? All right. So I know I'm selling some type of tickets. So X and Y. I'm selling some type of tickets. So now I do have to read the problem a little bit. You're selling tickets for your high school basketball game. Student tickets cost $30. General admission tickets cost $5. All right, so now I know I'm selling student tickets and general admission tickets. So how many of each type of tickets did you sell? So X would be the number of student tickets. Y is going to be the number of general admission tickets. All right, hopefully everybody's okay with that. All right, now, are there any totals? All right, any totals? Yes, 350 tickets, $1,450. So 350 tickets and $1,450. All right. So when we do this one, what are your 2 equations going to be? All right. You think about the equations. How am I going to get something to equal 350 tickets? How am I going to get something to equal $1,450? Right? Erase the dollar sign because you don't need it. All right? I want you to think about this. Remember, this one with dollars. That one's with dollars. Think about what we did right here for the dollar amounts. All right? So in this case, you sold 150 student tickets and you sold 200 general admission tickets. Okay? Please email us if you have questions. All right, here we go. Pizza and breadsticks. All right. So, how much does each pizza cost? So, you'll notice they just want X. That's all they want. They just want one. They didn't ask for both. We'll do both just for practice, but you notice they're only asking for one. All right. And I'll set this one up because I'll show you what to do first. All right. So, X is the cost in dollars for the pizza, but I still need a Y value. All right. And this is going to be the cost in dollars for the breadsticks. Okay. Any totals? Seen any totals? Yes. A total of. A total of. All right. So there's our totals. So I have $29.50 and $23. Okay. So equation one. Equation one here. What was ordered? So Casey ordered 3 pizzas, 2 breadsticks. All right, so they ordered 3 breadsticks. How much did each breadstick cost? Excuse me, how much did each pizza cost? I have no idea. Plus, ordered 2 orders of breadsticks. How much did these breadsticks cost? I have no idea. But I know together it was $29.50. All right. And Rachel ordered 2 pizzas and 3 orders of breadsticks. All right, so 2 pizzas and 3 orders of breadsticks. All right, now here's the thing I wanted to show you. All right, I'm going to let you do it. All right, I'll let you solve. But in both equations, there's no variables by itself. All right, but since what they're asking us is how much do the pizzas cost, that's all they're asking us. All I want to solve for is X. So what do I want to have happen? I want the Y to go away. I want the Y's to go away. So what am I going to do? How can I force these Y's to cancel each other out? All right, let's think about that. Well, here's something. The signs are exactly the same. All right, those signs are exactly the same. So I need to make one of them different. How can I make one of them different? One of these, when I multiply, one of these has to be a negative. All right, one of them has to be a negative number. Well, if you look at 2 and 3, you didn't hear me say that number. 2 and 3, what number do they have in common? Well, 2 times 3 is 6, yes? So what happens if I multiply this top equation by 3 and I multiply the bottom equation by -2? If you think about it, 2 times 3 is going to give me 6. 3 times -2 is going to give me -6. Will those two cancel each other out? Yes. All right. All they wanted was just the cost of the pizza. All right. So the cost of the pizza is $8.50. But I'll do the breadsticks also. Cost of those little tick mark things means I'm ditto copying the same thing above. Cost of breadsticks is $2. Okay. Hopefully that helps, guys.